Hey, what's up, developers? In this video, we'll see a Leetcode problem container with most water. This is part of my Leetcode playlist. You can check out my playlist through the link you see in the top right corner. Just click that and see what's in there. And if you are new to this channel, this is Praveen. I'm doing tech and coding stuff in this channel. So click on the subscribe button you see below and also the bell icon right next to the subscribe button so that you'll never miss any of my updates. Let's get into the video. Okay, let me simplify the problem you see in the screen. It's named a container with most water. We have to return the area of a container which has a maximum size. So that's what the problem is. So we are given a non-negative integers like n non-negative integers. Like let me explain with the example. With this example, so we are given n integers which are non-negative because they are the heights of the pillars you see in this screen. Like so these two screen the blue region you see in the screen is the maximum size that you may get out of it. So you have to return this size, like it's 49. That so how it's 49 you will see. Let me analyze this picture and let me explain that how this question works, so this problem works. So let's analyze that. So as I said, to find the maximum area, we have to first find the areas, like different areas. Then we can compare those areas and we can eventually find the maximum area that which container has its. So let's do it. So actually, for finding the area, as you know, it looks like a rectangle, so we need height and breadth, like length and breadth. I said height as length. I kept height as length, and we can, if we know that, we can easily produce the area that we want for different pillars, like a different pairs of pillars, because we are at a time we are checking two pillars at a time. So if we found height and breadth with those two pillars, we can easily go on. So in order to find that, we can find the breadth by index 2 minus 1. Like you can see this index right here, like 8. These are the index 0 1 2 3 4 5 6. These are the index, and these are the heights you can see in this picture. So let me say some examples. Like first pillar is height of 1, and second pillar is at a height of 8, and third is 6. Likewise it goes on. So if you want the breadth, like a difference between these two pillars will be the breadth of these two pillars, like yeah, in this container, if we assume it. So index 2 minus 1, which is index 2 is 8, and 8 minus 1 will be 7. That's how it works. So, and also we need minimum height, like height of the container. So in this container, the blue region is the container, so it's the water. The blue region indicates the water in it. So we can get this much of water because it overflows here. So we can have, if we take two pillars, the height of that container must be the minimum sized pillars height. So here you can see these two pillars, it has a height of 8 and this has a height of 7. So the container's height is 7 because the minimum height of those two pillars will be the height of the containers too. So we have to find that minimum of two heights, so two pillars heights. So in that way we can find breadth and height. Like to find the breadth, the index 2 is 8 and index 1 is 1. So if we find the difference between that, it will be 7, and to find the height, it will be the minimum of two heights. So this is 8 and this is 7. The minimum is 7. So we are having height and we are having breadth. So what we do is just multiply that. So like in a rectangle, we can find the area of this container by multiplying these two, height into breadth, which is 49, which is the answer that you see in that example. So let's get into the implementation. So let's get into the implementation. Here you can see what I explained. The maximum width is 49. So you may think that this two pillars, you can take this two pillars which is of 8, both are 8. So if we calculate the height between like a area of this container right here, if we color this blue region, so if you fill it with the water, so this may look like a maximum area, but it's not maximum than this. So let me calculate this too for an example. So the height is 8 here, and the difference is this is 1, like index 1, and this is index 6. So this is index 6. If it's 8, 7, 6, so okay, it's 6 and 1. So 6 minus 1 will be 5. So 8 5s are 40. So this area is 40. It contains 4. I mean, the area of this container is 40, and while this area is 49. So only we are producing the 49 as result. So we have to find the maximum area that what we are gonna do is we are finding as many area that we can find, like from left to right. We are just using 2 pointers because we are using 2 pillars at a time. So we are just using 2 pointers, one from left and one from right. So we are just doing that. After calculating all the areas, like one by one, we are calculating the area between 2 pillars at a time, and we are checking it to the maximum area that we are having at the initial stage. So we are comparing that and we are producing the result. This is how it works, like yeah. So we need 2 pointers, as I said, 2 pillars we are checking. So left, which will be pointing to 0, the index 0, and the right, which will be pointing to the last element of the list or an array. It will be len of height minus 1, which is the last element, which is 8 here in this example. And we are having a variable called maximum area, which is initially set to we are having let me comment out here the height we need. Okay, the height we need, and we have to multiply it by multiply it by breadth. Okay, we are just finding that. So let me do that here. So the height will be, as you see in that example, so minimum of those 2 pillars height. So left comma right, the minimum of those. We can just give like this because it's not the just heights, it's just index of that heights. So in order to get that height, actually we have to give like height of left, that will be the corresponding heights. So height of right, so we have to produce that minimum of these 2 heights. So we get the height of that container, and we have to produce the breadth too. In order to get the breadth, like let me put a into mark that we are multiplying it, and we are having right minus left, which is, as I said below, we are just doing index index 2 minus index 1, which is here. Let's take this example. This index is 8 and this index is 1, so 8 minus 1 will be 7. So this is the breadth of that container, that particular container, and this is the height of that particular container. So initially this is set to like for this values, and we are having a while loop here. Let me do that. So while loop is left less than height. This is the condition given to the while loop. So we are just incrementing the left by 1 and right by decrementing the right by 1 according to some conditions. Let me say that in clear. So when those two are interfering, the loop will stop. Until that, the loop will run. So eventually we get almost all the areas that we want to get the maximum height, like maximum area that we want as a output. So if like a height of left is less than the height of right, we have to increment the left by 1. Okay, yeah, if the left of height, like height of left less than height of right, we have to increment the left by 1. And if the case is opposite, we have to decrement the right by 1. So let me explain that clearly. So height of left is in the first case, height of left will be 1 and height of right will be 7. So if 1 is less than 7, we have to increment it by 1, increment the left by 1. And now the case is opposite, the 7 is lesser than 8, so we are decrementing it by 1. So eventually we get to here and the loop will stop and we may find the maximum area that we want. So here I am calculating the current area, like for every left and right, there will be more combinations of these two numbers, like left and right. So we are having we are calculating that area, that current area, and we are comparing it to the maximum area, and we are replacing the maximum area with that if the area is greater than the maximum area. So eventually the maximum area will be the final output that we want to get. So in order to get the area here, the same formula goes. So let me copy that and paste it here. Yeah, so after calculating that, we have to produce the we have to replace the maximum area if the area is the normal area is higher than the maximum area. So in order to get that, max of area comma max area, it will do that. So it will produce the maximum of these two. So after that, finally we return the maximum area, so as an output. So I hope it will work. Let me check that through running the code. So we are getting an error. Yeah, it's just a silly mistake here. So I'm giving height instead of giving right. So change that. Left less than right, not height. Okay, let me run that again. Yeah, it accepted the test case, like a sample test case here. So we are getting the output as desired, like 49 here. So let me submit it so that we'll see that all the test cases are passed or not. Yeah, it passed all the test cases. So thanks for watching. If you have any questions or suggestions about the video, you can let me know in comments. And the exact code you see in this Leetcode platform, you will get it in my GitHub page. The link for that will be in description. Check out, please. So again, thanks for watching. Bye from Praveen.